Dear students, in this video we are going to see how to design single tuned amplifier. So as your name implies exactly, so this is a kind of amplifier which is going to tune the particular band of signal, that means the particular frequency signal. So at particular frequency only we are having the maximum amplitude, the maximum gain. The rest of frequency durations we are having only minimum amplitude. So this circuit consists of NPN transistor along with RLC components, of course a biasing unit and the input section as well as the output side. So let me start our design from component selection. So first we have to select transistor, NPN transistor BC107. So the same procedure already we have done in earlier experiments. So NPN transistor, and here I am typing BC107. Transistor is selected, and we have to pick up 1, 2, 3 number of resistors. So 3 resistors and 1, 2, 3 capacitors. So 3 capacitors and 1 inductor, 1 biasing, and AC power supply and CRO. So 1 inductor and 1 AC source, AC power supply, and 1 DC. So you can select either DC power or VCC. Both are same only, and of course the output RTC function generator. So now let me start our process from the base terminal of transistor. So the base terminal of transistor is connected capacitor C1, and other end of capacitor C1 is connected to the input power supply, that's AC source. So capacitor, the first capacitor, and their respective value 1 picofarad, that is we have to change picofarad. So the transistor is connected with respect to one terminal of capacitor, and other terminal of capacitor is connected with input AC source, and their respective specification 15 and 11 kilohertz. So 15 and frequency 11 kilohertz. Okay. Then across base terminal we are having 2 resistors R1, R2. Both are connected 20 to 10 kilo ohm. So we have resistor R1 and resistor R2, both are connected across the base terminal of the transistor, and the collector terminal of transistor is connected with respect to LC network, so inductor as well as capacitor. So we have a inductor and we have a capacitor also, and their respective values we have to check. So 10 microfarad, 10 microhenry. So 10 microfarad, 10 microhenry. Okay. and of course R1 R2 also we have to change. So R1 R2 22 kilo ohm, 10 kilo ohm. So 22 kilo ohm and it is 10 kilo ohm. Okay, now this LC network is commonly connected at collector terminal. So LC network that is commonly connected with respect to collector terminal, and the upper side of LC network once again connected. So the upper terminal also getting connected, and we have the biasing. This is a 12 volt that is directly connected at the mid of these two. So 12 volt is connected, and the upper portion of R1 is also connected with respect to the biasing. Yeah, that is also we have connected. Then coming to the collector side of transistor, there is a capacitor. So that value belongs to 1 microfarad exactly. It is available. The one end of capacitor is connected with the collector terminal, and other end is connected to positive terminal of our output section. So this is the positive terminal, that is E, and one more terminal we are having. So emitter terminal of transistor is connected with 10 kilo ohm. So emitter terminal of transistor is connected with respect to 10 kilo ohm. So we have 10 kilo ohm resistors. Now the transistor, the upper side all are connected, and coming to the bottom connections, and now the negative terminal of power supply AC source and the two resistors and the negative terminal of CRO all are gets connected with respect to ground terminal. Now all terminals are connected. You can give ground connection with respect to the common. So here we are having the ground terminal and it's be connected. So once again we have to verify the values. So 15, 11 kilohertz and 1 picofarad, 22 kilo ohm, 10 kilo ohm across R1, R2, 10 microfarad, 10 microhenry, 10 kilo ohm and 1 microfarad. So next we have to verify the output response of a single tuned amplifier. So before we are going to verify the results, so once again we have to check the initial conditions. So AC sweep, because we are going to check the frequency response of the single tuned amplifier, at what frequency we are having the maximum gain. So the output not yet connected. For that, whenever we want to measure the frequency response, we have to check at what terminal we are having the output. So here the C3 is connected between collector and output. So that terminal net name is 4. So that we have to add. So AC sweep, then output terminal number 4, that is added. Okay, so now everything is over. Now we are going to check the response of single tuned amplifier. So here, as you can see very clearly, so we have a response at a particular point. Only we are having the peak value, that is peak gain. Remaining durations, remaining frequency durations, we are having only minimum response only. So here, if you add data label, I can see exactly 16 kilohertz we are having the maximum amount of gain. So as we told earlier, so single tuned amplifier which tune a frequency with respect to particular band only. This is the response of single tuned. Thank you, students.